Hello everyone, welcome back to my YouTube channel. Today we are looking at another problem from the Blind 75 list of problems, and this problem is named minimum window substring. It is marked as hard, and it might look hard at first, but once you get the idea of how to solve this problem using the sliding window technique, it is pretty straightforward. Now let's go through the question. So we're given two strings s and t of length m and n respectively, and we are supposed to find the minimum window substring of S such that every character in T is included in the window. And if there is no such substring, then we return an empty string. We are also given that the answer is unique, so that means there will be no duplicate answers such that we have to select the first one or the last one first. And let's now understand it with the first example. So the first example is we are given a string S called Adobe Code Bank and a string T which consists of ABC. Now what I am supposed to do in this question is find a substring in S that contains all the letters of T. So that means I'm supposed to find a substring in S which contains A once, B once and C once, at least once. So one substring that I can find is this. So it has at least one A, one B and one C. Another substring that I can find with A, B and C is maybe this one. This also has ABC. And another substring that I can find is this one. Now among these, I have to return the shortest length substring. So the shortest substring here is this bank, which consists of B, A and C, all of those which are present in T string. Let's see the other examples. So if S is A and T is A, then we just return A because A is definitely present here. And if we are given double A and the S string contains only a single A, that means there is no answer, so I just return an empty string in this case. We're also given that the length of both the strings can be at max 10 raised to the power 5 and both contain uppercase and lowercase English letters. And we are given a follow-up that could we find an algorithm that runs in O of m plus n time. So let's look at how we'll solve this problem. Now let us say we are given this first example with string s and t, and what we do is we take a sliding window like we used to do in the earlier questions, and we keep expanding rightwards until we find a string that contains all the letters from T. For example, initially this is A. A is there in the string, but I still don't have B and C. I keep expanding rightwards. Still, I don't have any of B or C. Now I get a B, but I still don't have a C. So I still expand rightwards. Now I got a C. So that means now I have all the letters in the substring from the string T. So my window size is this now. So that means I got a valid substring, which can be one of the answers. So I'll maintain a res here. And exactly how will we decide that we have found the target substring or not? We'll need to have a frequency map for this T string. So for that we'll create a hash map. So that will create consists of frequencies of each letters in this T string. So A occurs once, B occurs once, and C occurs once. Now what we want to do is maintain a similar hash map for the window we are currently considering as well. So for example, when I reach my window reaches here, my hash map will look like A occurs once, B occurs once, and C occurs once. I don't care about the other values, so I'm just ignoring those. And once I have this, that uh, the values in my window hash map are greater than or equal to my target hash map, each one of these, that means I have a valid substring. And then I can find the corresponding length of that substring and push it to res, and at the end find the minimum from the res. Okay, I hope you got that. Now let's see how we'll simulate this. So let me just clear this. So let's start from the beginning. We start with A. A is in our target hash map. So we insert A into the window. Now move on to D. We don't care about D because D is not in our target hash map. Move to O. O is not in our target hash map. Ignore. B is in our target hash map. So we increment B to 1. Now E is not in our target hash map, so ignore it. C is in our target hash map, so increment C for the window to 1. Now every time we find something in the target hash map, we'll also compare these two hash maps from top to bottom and check if these are greater than equal to the target values or not. So we did that once here, and once here. And once I have all like 3 letters, uh, the frequencies of those which satisfy this condition greater than equal to, and that means I have a valid substring. So now what I do is calculate the length of this, which will be 6, and also find the left and right pointer. So this will be 0, 5. Now once I have a valid substring, what I'll do, I'll start decreasing L. So I start decreasing L from this side, and I remove A from my window. So once I remove A, this becomes 0 and my condition becomes false. So that means now my L is fixed at D now. Let me just mark that. Now my L is here and my right pointer is at C. Now I again start expanding R. O is not in the target hash map, D is not in the target hash map, E is not in the target hash map, B is in the target hash map. I again scan this, but A condition is still not fulfilled. So that means I need to keep expanding. B will become 2. Forgot to update that. Now I reach A. A condition is now fulfilled. So I'll make this A 1 now. Now these conditions are all fulfilled. So that means I calculate the rest again. So this will be now R minus L, which will be, I think, 6, 7, 8, 9, 10, length 10, and left and right ends will be 1, and this will be 1 and 10. But as I already found a lesser length substring before, as 10 is greater than 6, so I'll just ignore this because previous value was smaller. Let me just clear this. So this is still my res. Now what I do, again I start moving L rightwards. So move this here, doesn't have any effect. Move here, we reach B. Now when I move from B, it won't have any effect again because B's frequency was 2. Instead of 2, it will become 1. My condition will still be valid. But as we are removing these insignificant characters, we'll also find new values of res here. We'll only update res when res becomes less than 6. Keep moving rightwards. So move here. I see. These are all still 1. And at C, my length is, I think, CODEBA. So this is 7 in length, and left and right ends are 5 and 10. So 5 and yeah, 5 and 10, and yeah, this length is also 6. But as I already have a 6 length, so I don't need to update it. So ignore this as well. Again, move left pointer rightwards. So L was here, R was here, sorry. And now when I move L leftwards, that my string will become invalid because C will become 0 now. Now again start moving R rightwards until I find a C, reach here, I found one more C, so again this C will become 1. And now again I start moving my L pointer rightwards until this condition is true. That means I have a valid substring. So I'll reach D, E, and at the end I'll reach B. Now once I reach B, my length is 4 and left and right ends are 12 and 9. So this is smaller than 6. So that means I'll remove the old answer and this will be my new answer. Now I again, when I start moving L leftwards, here it will become invalid at A. So this will become invalid. So once it becomes invalid, R I'll again move to the right. So once I move R here, that means I'll need to close my loop now and I'll return this result. Now if you look at the worst case, we are iterating this S string of M length, and for each match we are iterating a map also of length M in the worst case because length of T is N. So in worst case this complexity would be O of M into N, which are both 10 raised to power 5 into 10 raised to power 5, which is a lot. Now we'll need to reduce this time complexity somehow and find a workaround so that we can remove this effort that we are repeating again and again on each match. Just to reiterate on what the process we are repeating here is, for example, I was at this substring ADOBE, Adobe, and I've not taken in consideration C right now. So when I reached A here, I already know that A's condition is fulfilled and B's condition is also fulfilled. So when I reach C, I don't want to recheck in the hash map that A and B's condition are fulfilled or not, but only check for C now. So what if I maintain a separate count called match count, and this match count I'll update whenever I find a match for a specific character. So this I'll update when the frequencies become greater than equal to target for a particular letter in the current window. So for example, when I reached A here in the sliding window, I update match count to 1 because the target frequency for A was 1 and I reached 1. Similarly, when I'll reach B in the sliding window, I know that I want to find B uh, uh, by doing the O of 1 find in this target. And I can check the B's frequency in current window. This will also be O of 1. And when I reach that target frequency for B, I'll just update hash count, match count, which I'm doing here. So 1 will now change to 2 here. And similarly, when I reach C here, this will get updated to 3. Now, one thing to notice is that when this reaches 3, I'll use that as a cue to say that my current window substring is valid and I need to check rest. But how will we do that? With what will we compare this match count to? Match count will be compared to target.size. So size of my target hash map, when it becomes equals to match count, that means I have a valid substring now and I can update rest now. Similarly, when reducing L, my match count will come down because A's frequency will go to 0. So that means my target, this condition is not being met, greater than equal to. So match count will become 2 now. So that means this is not a valid substring now. And similarly, when it becomes valid, I'll keep updating res and just use this match count variable instead of iterating the whole hash map every time to reduce my time complexity. So what will be the time complexity now? Now for this complete string S, what we are doing is either inserting into this window or removing from this window. And both of these operations are O of 1. So that means my overall time complexity in this case is O of M, which is very optimized from the previous time complexity. Now let's see how we'll solve this in code. Now we are given a function called min window with the input strings S and T. Now let's first of all start by creating the hash map that we talked about initially. So first we'll create a target hash map and then create a window hash map. So let's start with the target one. So another map, yeah, int target, and for auto character in T, target of ch plus plus. Also create one for the window. So unordered map parent window, and also let's create variables for match count and result. So match count initially will be 0 and result let's take initially to be a very large value. So for example, int max. This we are doing because of this case. Cases like these will use this value to return the result. We'll see that later how we'll do that. We'll also need the left and right ends of the result. So to print the final resultant string. So I'm setting those to -1. Okay. We'll also need left and right ends for the sliding window. So take those as L and R. And initially both are 0. Now let's start with the loop for the sliding window. So while R is less than S dot size and R plus plus, this is for increasing the size of the window. And here I'll do, let's find current char. So which will be S of R. And if my target hash map has this value, so let's say if target dot find this current char, if it has this value, what I want to do is add it to our current window. So in this window hash map, I'll add this. So window char plus plus, as simple as that. Now what I want to do is, if the frequency which I'm increasing, so if window char becomes equal to the target frequency which I have. Remember I discussed this. So if it becomes equal to the target frequency, what I want to do is increase this match count. So this is for expanding the sliding window. Now let's write code for decreasing the size of the sliding window. So while I is less than equal to R, and I'll keep doing the decreasing the size of the sliding window until my match count is equal to my target size. So target size. And to decrease the size, here also I'll take this curchar variable. So to make the readability easy, so curchar is s of L now. And here I'll check if, so while this condition is true, that means my string is substring is valid. So here I can update the result. So if the current length of the string is less than the already existing value of result, that means I'll update the result. And along with that also update the left and right ends for the result. So res L will be now L and res R will be R. Once I've updated the result, what I want to do is increase the left pointer for the sliding window. And before I'm increasing the left pointer, I also want to reduce the frequency from the window hash map. So what I'll do is, if uh, the target has that value, so target.find curchar, if the target hash map has that character, and then I'll do target of target or the window. Yeah, I'll decrease it in the window. Target will not change. And once before I decrease it in the window, I'll also check if I'll need to reduce the match count or not. So if window curchar is less than target curchar at any point, that means my match count will decrease. Got that. We are updating res. I think that should be enough. Let me try this out. So here I'll return s dot substring from resl to resr, and substring function basically takes the length after resl. So this will be the starting pointer from where I want the substring, and second option is the second argument is the length of the string that I want. So that I'll calculate from resr. So resr minus resl plus 1. That should be the substring. And we're also given that if nothing matches, then we have to return an empty string. So for that, I'll use this int max that I assigned initially. So if res remains int max at the end of this, in that case, just return an empty string. Otherwise, I return this. So add that here. So this is a ternary operator. If you don't know, this is similar to an if else condition. So if this is true, I'll return empty string. Otherwise, I'll return this. Let's check it out if it works. Okay, compilation error here. One more. It should be sub str. Okay, two test cases worked. This one didn't. Okay, so here I am before decreasing the value of the character from the window. When I'm moving the left pointer, I'm checking if the frequency in window is less than the target. But here also I'll check equals to, because before decreasing the frequency, it will be equal only. And that is when I'll reduce the match count. And after I've done this, then I'm reducing the count from the window. So I think that was the issue here. Let's try running it once more. Okay, all the 3 sample test cases worked. Now let's try submitting. Okay, our solution worked. Let me just zoom out that so you can get a full view of this. Great. I hope you all liked the video. Do like, share, and subscribe to the channel. See you on the next video. Till then, happy coding.